Hello everyone and welcome to my channel. We're just gonna do this quick video on resistor color codes. We received a request by someone who wants to understand how to read circuit diagrams, and we thought we should start with the basic stuff, right? This channel for the past couple of months we've been concentrating on showing you how to do the basic stuff, and from there we're gonna build up and go to the more advanced things. So today we're gonna look at resistors. But let me show you an actual resistor, what it looks like. All right, let's get the video on. All right, so if you see what I have in my hand right now, what you have on the screen, this is a resistor. Or these are resistors, I should say, because there are a bunch of them here. If you notice, there are strips, color stripes on them, and this is what we're going to be discussing today. How you can identify what the value of a resistor by those colors that are on the resistor. All right, let's get right into it. Okay, so we the resistor is in a previous video. Please go watch that video. We talked about how to connect resistors in circuits in parallel or in series, and how to perform voltage divisions using resistors and all that. Today we're just going to look at how to identify the value of a resistor is solely on the color codes. So what I showed you on the screen a moment ago is represented. So let's just get some colors here. So this short end determines the beginning of the resistor color codes, and then the long end determines the end of the same. So in this resistor, we have 5 bands, 1, 2, 3, 4, 5. So we'll be referring to them as the band resistor bands. So you have 1, 2, 3, 4, and 5. So when we say bands, we're referring to these bands across the resistor. All right. So again, this is taken from a book written some time ago, manuscripts that we prepared some time ago when we used to teach some university students. So are significant digits. I'll tell you what it means shortly. Decimal multiplier simply meaning times 10 raised to a power of x. The x will be whatever value corresponds to that color. We're going to show you that shortly. The last band meaning across the resistor you have only 4 strips. So it will be 1, 2, 3, 4. The fifth one will not exist. This band will not exist. Okay, I can wipe it, but that band will not exist. Let's see if we can cover it. How about that? We can cover it, make it not exist in theory, let's say. Okay. So if it's a 4-band resistor color code, it would look this way. 5 bands will look like previous. All right. So what does it really mean? So let's look at the interpretation of those colors. We came up with this acronym a long time ago, and coincidentally, I found on the internet some people have something similar, very similar to the 2004, I believe so. We wanted it to read seamlessly down. So it goes like this: bad boys rape our young girls, but virgins grow wise selling gold now. We wanted it to read that way. And so what this helps you to know is, or to remember, is what number corresponds to what color. Is 1, red, 2, R, 3, and so on and so forth. And then these translate to black, brown, red, orange, yellow, green, blue, violet, gray, white, silver, gold, and no, I want to use it in a circuit. We're gonna go back to the table. The first table we looked at, which is this. Actually, we didn't look at a full table. We looked at figure 1, but 1.1, we didn't look at 1.2. But it's similar. So bands 1, 2, and 3 for 5 bands, they are significant digits. For 4 bands, 1 and 2 are significant digits. Band 3 is decimal multiplier, and band 4 for band 5 band resistors is the decimal multiplier, The last band of each is the tolerance band. All right. So this table simply summarizes what we have above. For 5 bands, you have first, second, and third significant. For 4 bands, is first and second that are significant. Tolerance of that resistor. So let's go back to our example resistor here. Green, what is green? Where is green? Looking for the table. Yeah, green is 5. We're gonna look at, since everything is green, we're just gonna pick the green out. Green is 5. So remember, for 5-band resistor color codes, band 1, 2, 3 are significant digits, SD, S underscore D. Fourth band is the decimal multiplier, D underscore M. Fifth band is the tolerance band. All right. So 5, 5, 5. The fourth one is a decimal multiplier. So we're going to do multiply by 10 raised to power x. In this case, our x is 5. Raised to power 5. And then the tolerance band is also green. What does green mean on the fifth band? Is plus whatever value of this resistor is, it's actually going to be more or less, 5% of the value, greater or less by 5%. So this resistor will actually be 5, 5, 5 times 10 raised to the power 5 actually means 5 zeros. So just write 5 zeros. So the actual value of this resistor ends up being 55.5 megaohms, plus or minus 5% of that value. So when you measure this value, it will be from 5% less than this to 5% more than this. Okay. The actual value, when you measure, it's going to be 5.5 minus 5% of that to 5.5 plus 5% of that value in millions. All right. So we're going to do one more example, and I think this is very, very basic, so we're not going to go in details here. If it's a 4-band resistor color code, just ignore the first band and treat them accordingly, just like we showed in this table. Ignore the first and treat the second as first, the third as second, the fourth as the third, fifth as the fourth. And you treat of the 1 kilo ohm resistor. The very first question you're going to ask me is, how many bands are the colors? Right, because this is going to determine the colors, and you're going to determine what factors you're going to be using to determine to judge. I'll give you an example. If I do a 5-band resistor color codes here, let's use 5. Let's say this is a function. We're going to make it 5 bands, right? So for 5 bands, it's going to be first, second, third, all significant. Fourth, decimal multiplier. Right. So let's use 5 bands then. How do we get 1,000? 1,000 really is 1, 0, 0, 0. Ooh. So the first band is 1, and we know from this table that 1 is brown. So the first color is going to be brown. The next color is also a significant digit, but it's 0. The third one is BL, blacks, 2 blacks, right? Now, the fourth band is a decimal multiplier. We know that. What can we multiply? What color corresponds to a value we can multiply to give us just 1 0? In other words, just 10. 10. 10 times 10 raised to power what will give us just. The next color here is going to be BR, which is brown. Okay, so this resistor will be brown, black, black, brown. If you want to go backwards to prove this, so you're gonna brown gives you 1, black, since there are 5 bands, remember there's another band here we haven't talked about, the tolerance band, right? So brown gives you 1, black is 0, everyone knows that. Another black is also 0 since it's 4 bands. The fourth one, sorry, is the decimal multiplier. So you're just gonna write down 10 times before you look at it, before you go any further. 10 times raised to power what? X, and X is brown. And what is brown? Let's look at the table. You guessed it, it's 1. So this will be 1,000, right? Or 1 kilo. Not really, many of the common ones that we use are not really 5 bands. Many of them are 4 bands. So if you are used to the 4 bands resistor color codes, you might be screaming right now saying, no, it's wrong. So let's just walk through the 4 bands resistor color code for 1 kilo ohm resistor. 1 kilo ohm, 1,000. Time around, it is our function is now 4 bands. Okay, so which means only 2 digits are significant digits. Only 2 digits are significant digits. In this case, first and second are significant. Third is a decimal multiplier. The fourth is the tolerance. So there's no confusion right there. Okay, so why don't we just do that multiplication right now? So first band is brown. Everybody knows that by now. Brown. The second is significant as well, black, right? But now the third is a decimal multiplier. Remember, we're talking about a 4-band resistor color code. So decimal multiplier, we need, what does brown is 1, black is 0. We need 2 more zeros. What do we multiply by? What do we raise to? What value do we raise 10 to get 100? We just need 2 zeros, so that means 2, right? And what value corresponds to in the table? You guessed it, red. So it's going to be brown, black, red. So this color here is red. So now this is what many people are familiar with. You're going to see brown, black, red. And then, of course, take care of the tolerance. Whatever value it is, plus or minus, whatever value, percentage, plus or minus value, then percentage. So this is where we're going to be ending today's video. Please keep coming back, and I will be doing more tutorials like this, building up for the big weekend projects. All right. Remember to subscribe, tell your friends about this channel, keep coming back. We're going to be making another video. Someone has so we have so many of those projects. We had left them in our other office before the lockdown, so we're going to be getting new supplies to reduce some of the projects that we planned, and there are so many of them that we also have in this current office. Just that we're getting through the basic stuff first, because we want people to be rooted and grounded to understand these principles properly. All right, so I'll see you in the next one. Please remember to subscribe, tell your friends about this channel, keep coming back, and we're going to be providing you contents. There are quick videos we've done before, and we're going to be doing that even in the future, where you just go watch the video and do it yourself. But right now we're trying to build the background, the foundations, because there's so much, there's a lot that go into the circuits. One thing you get from my channel, not only can you just build something quickly, but also you get a foundation, you get the principles, you get the theories, because theory and practicals, they need to go together. When you have just the practicals without theory, it's like one leg of the stool is missing or something like that. So you need both of them. You need the practicals, you also need the theory to go together. I say that the practical without theory is blind, will not go far, and theory without practical will not even get started. So if you have all the theories but you don't have the practicals, you will not even get started. You can just talk about it. If you know all the practicals but you don't have the theories, you will not go far, because you only be restricted with what they told you. But now when you know the theory and when you know the practical applications, switches. We built transistor switches, built 2 of them and 3 of them, and we just added one capacitor on each of those transistor switches, and we built a light chaser because we understood the principle, right? So we understood how these things work. And that's how you can create your own circuit diagrams, when you understand how those small building blocks work. I also teach things about block diagrams, right? I teach you what a block diagram show you the block diagram, building block of that circuit, and then you can create your own. You don't have to really copy someone else, but you can actually, because you understand the principles, you can actually create your own circuit just purely based on the block diagrams. All right, so let's just keep doing that. Subscribe please if you haven't done so, hit that like button, and remember to click on the notification bell so that when I post another video, you'll be the first to know. This is not our weekend project. This is just midweek intermission, if you will. The weekend project is coming. We've shot the video already. We're doing the editing, so the video will be coming by weekend. We're going to be showing an interesting circuit, right? So we're going to be looking at it's a special sake. Let it be a secret for now. I'm struggling